doesn't let me do that. Okay. All right, so let me find it. It's down here somewhere. It's not that one. All right, that's the one I want to start with. Again, in the next 24 hours, you may be seeing this again, right? I wouldn't do this if it wasn't important. So I'm going to start with that one.
Is this from the hint?
This is from the hints, the book hints, okay? So, and again, I videoed them all yesterday. Sorry for all the coughing in the background and probably Special Agent Oso in the background too, but it's at least there. So, this one is weird, okay? You only want to do the add and subtract if it's really not connected well to a dy dx. I don't really want to subtract this over because it's not going to help me, okay? So I'm going to take this whole thing as one chunk and use division, all right? So to get the dx over, I would multiply, right? And then to get this whole chunk, it's times 1, so I would divide. It's weird, right? That's the way we do this one. All right, so we're going to integrate both sides. Remember, our goal is to solve for y. All right? When I have 1 over something, what does that integrate to? Natural log, absolute value of the mess, right? A lot of the books, or a lot of these, they drop the absolute values, okay? We don't have a U-substitution because what's the derivative of y? 1. So I kind of got away with not having to do that U-substitution there. All right, when I integrate this, what do I get? X, and I'm supposed to say plus what? That's the step I missed in the video, was I forgot my plus c, and that does affect it, okay? All right, so I'm going to go ahead and try to simplify this. How do we get rid of that natural log? We got to exponentiate both sides. And really, I remember the trick we learned last week was we have to write c sub 1, because I'm going to change the c by the end. If you didn't write that, I probably wouldn't mark it wrong, okay? But you want to make sure you write it. What happens with this e and the natural log? They cancel. So you've got y plus 2 equals. We want to break this up, okay? So whenever you see that, we break it into 2 bases. I don't know why I wrote 2 equal signs, sorry. X and c sub 1. Remember, the addition turns back into multiplication. What does that mean this becomes? C. So y plus 2 equals c e to the x. And then how do I move the 2 over? Subtract it. And just so you guys know, there's all those matching ones at the beginning. I think there's like 11 of them then that are multiple choice, and then 3 that are the short answer kind of questions. Okay, 3 that I'm really going to look at work on. All right, what else do you guys want to talk about? It's up to you. Let's start the hints now, because the other worksheet, there's just the 3 problems. So, Eric, which one?
39.
39. There's way more off of this than there are off the worksheet. Which problem? 39 on 366? Yeah. Is that the one you're looking at? Okay. About here, maybe? Nope. Make sure, again, you have your derivatives and your integrals memorized. That one right there? Okay, so what rule do we have going on there? Product rule. And I kind of gave you a hint which derivative we needed. So g prime of t equals, keep the first. Derivative of the second is this guy, the a to the x. So I have to do, we were doing the natural log of a up front. I borrowed this from another publisher. Natural log of 2 times the function the way it looks, right? And that was just the first part of the product rule. Keep the first derivative of the second. Keep the second. What's the derivative of the first? 2t. Now, from there, it could be left like that. They could do a greatest common factor out. I have a t in common, and we have this 2t in common. So they could pull out t times 2 to the t, and then left behind I would have, what, t natural log 2 plus 2. So, and either one of those are good answers. I don't know if I put that one on. I don't think I did. All right, what else? 37, same page as the first one. Okay. Definitely something basic like that's going to be there probably, okay? So really straightforward. The derivative of 4 to the x. So we do natural log of the base. So what's the base? 4. And then we take that and write it exactly the way it looks. 4 to the x. Done. All right, are there, what else? Nothing? We're ready for it? 367, 63. Okay. That one? Okay. And notice I gave you the integral. Remember, the first thing one of the first things you're gonna do is you're gonna match your derivatives. So I did the derivatives all together and I did the integrals all together. There is only one integral that has a natural log in it. It's that one. Okay? Because the other 3 are the inverse trig. You should be able to match that one. Go back and use those. Okay? When you're, I let you have the paper in front of you with all the formulas on it. Use them. Okay? All right, I'm going to use U-Substitution. What do you think you're going to use as your U? You're going to just use the negative x squared this time. There was one on yesterday's, and that's one that's on the test, that number 7 from yesterday, where you use the whole thing, okay? But we're just going to use the x squared on this one, yeah.
Can you use the whole thing?
You might be able to. I don't know. I did it with just this, and I got it.
Because I did it the other way, and I got it.
You got it? That's fine. Okay, if you can get it to work, that's fine. So I've got du is equal to what? Negative 2x dx. I'm going to move the negative 2 over. Equals x dx. So I'm going to sub in. So I get 5 to the, what? U. And then x dx, I'm putting in negative 1/2 du. All right, when I integrate 5 to the u, I'm using this formula right here. So my a to the u goes up top. So I'd have 5 to the u. Natural log of the base. What's my base? What number is my base? 5 plus what? C. Okay, we're going to put some stuff back in. I got to put in the negative x squared back in for the u. So negative 5 to the negative x squared over 2 natural log of 5. They do put on the test, I noticed the author put, or the tester, they like putting parentheses around their natural logs. I don't know why. All right, what else?
44.
44, 378? Okay. All right, I don't know why I grabbed arc cosecant, and I need arc cosine, right? Or arc secant. Let me see if I can find it. I wrote it down somewhere. Maybe. 44, where are you? 37. Are we up here? There it is. Okay, so the derivative for arc cosecant, and I know that some of them are written with that inverse notation. It's the same thing, okay? It's 1 over, if we put it into x's instead of a's and u's, it would be absolute value of x, square root of x squared plus 1, okay? So all I have to do is I have to fit that, all right? And anytime I see an x, in this case, I'm subbing in whatever's in here. That would be the u from the other way we learned the formula. So it's really, really straightforward, okay? So as long as you knew the formula and matched it right, you should be able to plug in for this. So what's going in for the absolute value of x? 2x. They may or may not have the absolute value marks around it. And then you're going to stick this in, square it, plus 1. They may rewrite it as what? 4x squared plus 1. There's nothing to it. It is plugging into a formula. Oh, I forgot something though. There's a chain rule, isn't there? What's the derivative of 2x? 2. So technically what happens? 2's cancel, don't they? So don't forget your chain rule. All right, what else? Nothing? I could give it to you right now and you do okay on it? 46 on the same page? Okay. All right, 46, we're going to apply this formula right here for arctangent. Remember that is also the arctangent of x to the 1/2 power. Okay. So we've got the derivative equals, it says 1 over 1 plus x squared. So 1 over 1 plus x squared. What's my x right now? Square root of x. Okay, I also, before I go and simplify, I need to do the chain rule on this, don't I? So the chain rule would say bring the 1/2 out in front, x to the negative 1/2, because I got to subtract 1. All right, now let's try to simplify. What happens with the square and the square root? Cancel. So we got 1 over 1 plus x. And then we've got this 2 would be hanging out in front. And then this would go downstairs and under a square root. I know that looks weird, but that's about as simple as we could get that one. I highly recommend we do 41. Okay? Let's look at 41 out of those 3. Let me go back without jamming. There we go. Okay, so this one is this arc sine one. Again, this one on the test is not a multiple choice, so you don't need to simplify. Okay? All I want to know is, do you understand how to apply the formula to the derivative? So the 2 is going to stay 2. Okay? Arc sine's derivative is 1 over square root of 1 minus x squared. What's going in for the x squared part? X minus 1. Done. Don't simplify it. Leave it like that. Yep. Well, if it was multiple choice, yes, but this one's going to be that one's going to be a short answer. Okay, so don't simplify. Okay? Again, you need to make sure you understand which formula is which so you can match it properly, right? Again, you don't need to learn cosine, you need to learn secant. All right, what else? 42 on the last page, 429, is that right? Okay.
So you said we don't need to know secant?
You need to know secant.
Okay.
You don't need to know cosine. I accidentally grabbed a cosine. Oh, 42, that last one we're going to get rid of. So skip that one. But let's do the one before it. Let's do that one, okay? I would make sure I know how to do this one. I believe this one is also a short answer. I think the only thing I changed was the 4. Okay, so it's the identical problem. All right. So we're going to start by writing the y prime as dy dx. Okay. And I'm going to move a couple things. This is the one instance where we do the add and subtract. So I'm going to move that e to the x over. How do I do that? What do we have to do, guys? Add it to the other side. Okay. And then I got to move the dx over. How do we move the dx over? Multiplication. Good. And we're going to go ahead and integrate. When I integrate y, what do we get? Y squared over what? 2. When I integrate e to the x, we get e to the x plus c. So even though e to the x and natural log aren't on our lists for our matching this time, you still need to know them. Okay? And I'm going to call it c sub 1 for now. All right, so from here, I'm probably going to start by getting rid of that 2. How do we get that 2 to the other side? Technically, we're going to multiply, and that means I'm going to distribute it, right? So I've got y squared equals 2e to the x plus 2c sub 1. Isn't that 2c sub 1 still a constant? Mm-hmm. Yeah, so I'm just going to rename it generically as c. Now, this one is short answer because I really want to see this work, because this particular solution business I need to make sure you can do. Okay? It's more important than the derivative of the log and the a to the x, or even the inverse trig. Yeah.
Why did 2c sub 1 turn to c?
It's still a constant, right? 2 times a constant, still a constant. So we just made it a generic constant, okay? All right, so what I'm going to do now is I'm going to plug in this initial condition. So what's going in for the y? Careful. 4, right? That's your y. Your x is always in parentheses. So what's 4 squared? 16, okay? 2e, what's going in for the x? 0. What's anything to the 0 power? 1. So 2 times 1 is 2. So what does c have to be? 14. And then I got to go back to this function right here, and I have to rewrite it with the 14 in there for the c. You can leave the y squared, okay? But you got to get rid of the c. It's probably one of the more important things that we make sure we know going into the AP exam, because it's in there a couple of times. All right, what else? Are there any others that you aren't sure of that you want on the hints in the book that you want me to go over? You probably want to do number 41 from the first page. Or no, so is it 41? 43 from the first page. Let's go look at that one. Okay. There were very few that I could pick that had the derivative of the log in the test bank. Okay, so this is the one it was. I want to say it's something like x squared plus 7 over x squared plus 1, so the chain rule is a little bit more in depth than it is here. So the first thing we're going to do is not take the derivative, but we're going to use our log properties. What does division turn into? Not multiplication. Subtraction. So log base 2 of x minus 1. Now I can take my derivative now that it's split up. Okay, because you don't want to do a chain rule that's got a quotient in it. That's a mess. Okay, use the log properties to help you. All right, so I'm going to start. I do have the little chain rules in there. Okay, but it's better than it was. We're going to take the derivative. It's going to be that. Okay, so we've got 1 over, what's my x right now? X squared, good. And then what's the natural log of the base? Natural log of what? 2. What about the chain rule piece for that? What's that going to be? What's the derivative of x squared? 2x, good. Minus, all right, I know it's got to be x. What's going in for the entire x this time? Good. And then the natural log of the base, what's the base? 2. And then chain rule is just going to be a 1, isn't it? Okay, couple of things I can do. All right. First of all, I could cancel this x with that one, couldn't I? All right, and I'm going to kind of be lazy a little bit, and I'm going to factor out in this same step. Do you see the GCF sitting here? See that natural log of 2? I just want you to make sure you're aware of that in case this comes up on the multiple choice. I could take that out, but when I take that out, there's technically a 1 on the top. So it could be 2 over x minus 1 over x minus 1. Or they could leave the natural log of 2 in it. Okay, they kind of have an option there.
Would they ever put it over a common denominator?
They could. I don't know that it's like that. I'll see if I can. I know that one's on the test. I will look again and see what they did with it. I don't think that we did. I tried not to change the problems from the test bank because I would mess them up and then there wouldn't be a right answer. So, especially with as foggy as my brain has been the past couple of days. All right, are there any others that you want to see from the hints? Two on page 385. Okay. Let's see, we're on 43. Otherwise here. So, was that it? Did I grab the right one? Really? Awesome. Okay. We got to do an inverse trig, right? Which one of these three is it looking like the most?
Would that be on the test on the side like that?
Nope. It's going to be in your matching. Right? You're right, it's the first one, right? It looks most like sine. Excuse me. All right, so let me do some rewriting. Excuse me. Might hack up a lung that I'm here. Okay. We're missing the derivative of that, right? Two ways I could deal with it. Shorter of the two is to just add the number in. Okay? I could do a U-substitution or a P-substitution. What's the derivative of 2x?
2.
Whatever you do to the top, you got to do the bottom, right? Excuse me. Okay. Maybe I'll stop now. Now it fits the pattern exactly over here. So I just use this. So arc sine of, what's the U value? What's my A value? That's it. That's all there is to it.
Those formulas are going to be on the test as well?
They'll be matching.
Okay.
Yeah.
I have like a question, but it's like a question on like personal preference on like how to do it.
On what?
Personal preference on how to do.
I don't care.
Yeah, because it's just like take out the 3 and then add a 2 to both the top and the bottom.
That's fine. Like I said, the other way we could have done it is we could have done that, right? And moved it over. It would have worked either way. Okay, the other video shows the other way. All right, what else? Any others from hints you want to see? Nothing? Okay, are there any multiple choice ones you want to see?
We're going to do it on page 14.
Which one?
38 on page 14.
38 on page 410. And then which one, Stephanie?
Oh, I'll give you number 5 on the same page.
Okay,
That one.
let me do the 38, 410 here. Where did it go? 410, 38 goes. It's after that. I'm not finding it. Why am I not finding it?
Because instead of using 38, you use 37.
Oh, I use 37. Good. Is that what the problem is? All right. What's the 38 problem? Do we have it written down somewhere?
It,
Minus 4x. Okay, we got to move the dx over first, right? And we're going to integrate both sides. So y equals x to the... Add 1, guys. Minus 4x what? Squared over 2 plus c. Simplify it. That's what we've been doing forever, right? All right, and then Stephanie, you wanted 5 from 385, is that right?
Yeah.
Okay. That one?
Yeah.
Okay. Let's see if we can get this one to fit. Which one of the 3 is it going to fit? It's going to be the secant, isn't it? The arc secant or the arc arc secant. This one is 5. I want to make sure I do it right. This is that one. Okay, so again, I'm going to kind of rewrite it a little bit. I've got x. I know that this is really 2x squared minus 1. Really? I'm supposed to have these guys match, aren't I? Okay, so what would I have to add in to get this one to match this one? A 2. And you guys, you know what? That actually helps us because what's the derivative of this? 2. So it's supposed to say, I know I made a mistake on this one on the video. It's supposed to be a derivative on top, right? So it fits this pattern exactly. So I'm just going to do that pattern. I know that that's the U and this is the A. So we've got 1 over A. What's your A? 1, because right, it's really 1 squared. And then arc secant, or secant inverse, your choice. Our formula said absolute value, didn't it? It may or may not have that on the test. What's the U? 2x plus, over A, which is 1, plus what? C. So arc secant of absolute value of 2x plus C. All right, are there any others you want me to talk about? I just going to get to fit the pattern, right?
Yeah.
And that's the best way to see what your U really is, right? Is to take the square root of things. All right, are there any others on this on the hints that you want me to do? 53 on 410. Okay. That one? Okay. Not 54, just 53. Match the differential equation with the slope field. Which one looks most like cosine? B. All right, that one's not going to be on the test. Do you guys have your slope field worksheet? Get out the slope field worksheet. I'll tell you which ones are on. Okay? So that way you can be prepared. Okay? You can narrow down and not have to study the entire worksheet. As I said, that worksheet was fair game. Okay, on the front side, where you're having to sketch the slope fields, right? It gives you all the dots, right? I think you want to make sure you know how to do number 3 and number 5. Those are in the first column on the left side, right? Isn't one like x minus y and one's like y or something like that? Is that right?
X plus y and y minus
There you go. I knew it was something like that. So I'd make sure I knew how to sketch those two. And we're all okay picking a point. So I pick 0, 0 to start. Graph my slope. Pick what? Out 1, up 0 would be what? A slope of 1. So I draw a slope of 1 at the next one. Does that make sense? And we've done all that. I put that on there so it would be easy, right? I want you to have a couple of questions that are really manageable. Okay, now flip to the back side. The top of the back side, there's 4 graphs, right? And 4 problems that you have to match them to. It was like 1/2 x minus 1. Is that right? I know this one's negative x over y. Was this one a y? What was the other one? X minus 1. All right. Minus what? Y. Okay. So all you have to do on this one is pick a value, right? Like I would probably pick 1, 1. So if I pick 1, 1 and I plug it into each one of those. So if I plug 1 into this one, what do I get? Was it a minus 1 or was it a plus 1? Is it minus? Plus. Okay. So it's not the answer I got first period or 0 period. So what if I put 1 in, I get what? 1.5. So a positive 1.5 slope. When I put 1 into y, what do I get? 1. What would 1 minus 1 be? 0. What negative 1 over 1 is going to be? So what I would do from here is I could probably pick out 2 of the graphs and match them up right now, right? I'm going to go to my graphs and I'm going to look at the point 1, 1, and I'm going to find the negative 1 slope. Isn't it graph A? Look at graph A. Doesn't it have a negative slope at 1, 1? And it should be the only one that has that, okay? And then one of the other graphs, if you look, is going to have a 0 slope at 1, 1. And so that's the one that's going to match the x minus y. Okay? This one is always the circle. That negative x over y is always the circle. And then from there, pick another point. Whatever graphs are left, look for a point like maybe 0, 0 or negative 1, 0 or something like that, where the slope looks different, and then that way you can match that up. Okay? What's wrong? Okay. All right. But I'd make sure I know the 3, 5, and those 4 graphs from your slope field worksheet. Okay. All right. Are there any others that you want to talk about from the hints? What about from the multiple choice? Are there any from the multiple choice you guys want to talk about?
Can you cover the ones that are going to be on the
The 3 multiple choice are going to be on the test? Yeah, we can do those real quick if you want. Yeah, take the pass. All right. I don't know if I have the multiple choice worksheet up. Nope. Let me find it real quick. Dropbox. Okay, so the 3 I said were 2, 5, and 7. Let's start with 2. This is another one with that nice log. So it's hard to find those kind of problems, so that's why we were picking on that one. The 1/4 is going to stay 1/4. So it looks like, let's see, the derivative was 1 over x natural log of a. Is that right? Make sure I'm right. Okay. So it's 1 over x. What's your x value here? 5x squared minus 9. And then natural log of the base. What's the base? 2. And then we got to chain rule it, right? Because this is an inner function. So what's the derivative for the chain rule? 10x. Okay. So let's see. If I was going, it doesn't even look like I have to simplify anything, right? Move the 4 in, move the natural log of 2 up. Doesn't that look like one of the answers?
Why does the negative 1/4 stay there?
Because it's just a coefficient. Right? Doesn't that coefficient stay when we take the derivative of 2x? Yeah, it just stays. It's a coefficient.
So when we have the log base and then whatever's in the parentheses, you use that on the one over.
Yep.
Natural log.
Yep. Okay. All right, we good with 2? All right. Look, they didn't even simplify the 10 and the 4 in their multiple choice. That's interesting. All right, let's look at 5. Can't get much easier than this. It's literally applying the formula, right? When I integrate, I don't remember off the top of my head. When I integrate, my formula is a to the u over natural log of a. So a to the u over the natural log of a plus c. So what is my a to the u? 5x over the natural log of what? 5. Nobody should get that wrong. Especially since there's only one of those, and you should be able to match it early on in the test. Yes, Tanisha.
So A is like your base?
A is the base. Always.
Why on the video did you write integral a to the x equals 1 over natural log a times a to the x?
It's the same thing. It's the same formula. I just rewrote this formula differently. Okay. All right, and then the last one was 7. Was the other one that was important. All right, this is the one where I took this whole thing as the u, right? Actually, no, I take that back. I took just the 4x as the u. Or 4 to the x is the u. And let's take the derivative of that. So the derivative of 4 to the x is the natural log of the base. What's your base? And then times the function the way it looks. So this one, okay, the 1/2 hangs out. This whole thing gets replaced with du. Really, that's it, right? So we're going to integrate that. You get 1/2. When I integrate du, what do you get? U plus c. So 1/2. What's the u? 4 to the x plus c. Thank goodness it's not answer choice B, right? That one's kind of nasty. All right, so those are the 3 from the multiple choice I'd make sure I concentrate on. You guys really, really, really work on those formulas. Okay? That's really the key to the whole test. It's applying the formulas that are there. So you have to be able to match those formulas. Yeah.
So why did you add natural log to the 4?
Because that's the formula for the derivative.
Oh, okay.
Yeah. You just got to get them memorized. Okay? All right. Are there any others you want to talk about? Okay. What else is due tomorrow? Your notes. So you need to make sure the summaries and the table of contents are updated. That needs to come in at the beginning of class. I'll make sure the little stickers are out at the beginning of the day. Okay? Make sure you're here on time. Make sure you're here because we only have Friday at lunch to get it made up. Okay? So before I put it in for the triad. So you don't want to have to do that. What else did I say? Oh, did I tell you office hours tonight? I will be here from 5 to 6 p.m. tonight. Okay? So if you want to come for office hours and you need more help, that's fine. If not, the videos are up there. I'll try to get the couple of mistakes taken care of so you don't have the mistakes in the videos. Okay? All right. Oh, what's Friday? End of the triad, which means I need to see up through week 5 by Friday. Okay? Week 6. Excuse me, I'm not counting. My plan for Friday is to do some kind of short lesson to start chapter 7, and that'll count for the last 2 stamps. You won't even have the end of week 6 homework till Friday. Okay? Because I know we've already got the first 3 covered with the study guide. Okay? Any questions? Yes?
Do we come later today for C's candy?
Yes, so C's will be divided up. Third period's going to divide it up. So you're welcome to come anytime after 3rd. I'll send out the text message. If not, you can get it tomorrow. Okay?
You said office hours or today?
Office hours 5 to 6 today. Okay?
Yeah.
All right.
Not hacks and
We'll see if I'm still hacking up a lot.
I'm only been here once.
Yeah, if you want me to stamp, let me just shut this thing off and I'll stamp.